Hi, welcome back. In the last video, we got introduced to geometry and we understood about points. Then we got to know about line segments and rays, and we were about to start with angles. Before moving ahead with the angles, as we said in the introduction of geometry is measurement of earth objects of different sizes and shapes, and what you want to measure depends upon those objects. Suppose for a triangle, you maybe want to measure the side of a triangle or angle between two sides, area of the triangle or perimeter of the triangle, or maybe for a circle you want to find out the radius of the circle or the diameter or the perimeter or the area, depends upon the requirement. So let's move ahead with angles. We'll just go ahead with the angles, right? So what we'll be covering in this session is what is angle, how the angle is denoted, what are the different types of angles, and also we will try to find out what is the relationship when the two lines are intersecting with each other. Okay, we'll start with the angle and how we denote the angle. Suppose I have a straight line. Sorry. Suppose I have a ray A and I have another ray B. So that's what we learned in the last video, that they are either closed or open. How much? That's what we want to know with the help of angle. So the angle, before going to the angle, this common starting point we call it as vertex. O is called as vertex, and A comma B are called as arms or sides. We call them as sides. So how we denote the angle? We denote the angle by saying like angle. The shape is almost like you are trying to find out the angle between two sides, something like this. Then we will keep the vertex in the middle, and the rays between which we are finding out the angle, that we will write here. So can be this is absolutely equal to angle AOB. So whatever is convenient to you, either you want to go this way or that way. So that's how we denote the angle. And so that's about the angle. The first impression, why we want to write BOA or AOB, I can simply say angle O. Yeah, seems to be okay for this scenario because it's only two rays are there. Suppose I have added another ray, then there is another angle. Now I say angle O. I am not specifying between which rays I am calculating the angle. It can be between CB or BA or between AC. That's why we follow the notation of the vertex in the middle and the rays on the left and right side. So it's a COB or BOC. Okay. And also, if you see here, there are two angles. There are two angles, but you can observe that these two angles are having a common side. So angle COB, that's angle COB, and if I take angle, next angle, that's angle BO and A. You see that OB is common, so we call that as common side. We call it as common side, and these two are called as, in this scenario, non-common sides. So that's about fundamentally about the angle and how you denote the angle, right? So we have seen the adjacent angles, right? Now let's, once we know actually how we denote the angle, you can see the types of angles which you should have learned already. Acute angle, these are all with respect to the 90 degrees you are saying. So that's why acute angle less than 90 degrees, that means 0 to 90 degrees. Right angle exactly equal to 90 degrees. obtuse angle between 90 to 180 degrees, straight angle equal to 180 degrees, reflex between 180 to 360 degrees. And these are the different types of angles which you will be seeing. Now let us take a special condition of whatever the adjacent angles we have seen. Now let us say that suppose I have a straight line. I am creating a straight line actually, and I have a ray here. So this is A and this is B and this is equal to C. So you can see here I have two angles and both of them are adjacent angle. Just now we have discussed what is adjacent angle. Adjacent angles always have a common side. So angle AOC and angle COB are adjacent angles. So if you see here, the non-common sides are making an angle of straight angle, that means 180 degrees. So this sum will be equivalent to 180 degrees. So which leads to a important conclusion that if a ray stands on a line, then the sum of the two adjacent angles equal to 180 degrees. If a ray stands on the line, then the sum of the adjacent angles equal to 180 degrees, or the converse of it is if the sum of two adjacent angles is equivalent to 180 degrees, then the non-common sides form a straight line. If the sum of two adjacent angles is equal to 180 degrees, then the non-common sides form a straight line. So these angles, okay, these set of angles are called as linear pair of angles. They are called as linear pair. So they are called as linear pair of angles. Okay, let's move ahead. I'm just erasing so that I'll go to the next topic. Just give me a minute. Okay, right. Or maybe I have, that's fine. This is yes and this is O, just for reference there. Okay. Now these are all pretty much clear, very simple. We have seen adjacent angles, and another case is complementary angles. If there are two angles, if maybe one case I will take something like this. I am taking a specific condition, okay? This may not be always the case. So what I mean is the complementary angles may not be like this only. They can happen in other ways also. OA, OB, OC. You can see that suppose this angle is 90 degrees. Then these two angles A comma B, if A plus B is equal to 90 degrees, then A comma B are called as complementary angles. AB are known as complementary angles. We have seen supplementary angles. Supplementary angles is when two angles sum is equal to 180 degrees, then they are called as supplementary angles. Linear pair of angles are supplementary angles. OA, OB, OC. Now what's the difference between linear pair of angles and supplementary angles? Linear pair of angles is a supplementary angle, but supplementary angle may not be a linear pair of angles because this is one particular condition. So these two angles, if their sum is equal to 180 degrees, then you call them as supplementary angles. If their sum is equal to 90 degrees, then you call them as complementary angles. Yeah. We'll just go ahead and we'll see what are opposite angles. Just give me a minute. I'll erase this so that Okay, I'm back. So let's look at this condition. We know that the lines are formed, right? The lines, what happens to the lines? Suppose there are two lines. Let's consider only two lines. We don't want to complicate the things. There are two lines. What can happen to them? Either they may intersect or they may be parallel. And when they are intersecting, they may intersect at 90 degrees or they may intersect at some other angle. So let's look at the condition. Suppose they are intersecting at a particular angle. Now what is the relationship between these vertically opposite angles? So you know that these angles are called as vertically opposite angles. Now this is O, this is A, and this is B, and this is C, and this is D. So I know that whatever we have gone through, that if non-common sides are making a straight line, then sum of the angles is 180 degrees. So I know very clearly angle, if I take the line DB, if I take the line, consider line DB, I know that angle DOA plus angle AOB is equal to 180 degrees. We just learned that. Similarly, if I take the line AC, if I take the line AC, DOA plus AOB equal to 180 degrees, and if I take the line AC, angle AOB plus angle BOC is equal to 180 degrees. So both are equal to 180 degrees. So if I compare them, I can cancel out this and this, and I get that angle DOA is equal to angle BOC. That means this angle is equivalent to this angle. Can you go ahead and prove that this angle equal to this angle? Yes, you can do that by taking lines CA and BD. If you take the lines CA and BD, you can prove that this angle is equal to this angle. So which gives us a result that whenever the two lines are intersecting, the vertically opposite angles are equal. The vertically opposite angles are equal. I think we are running short of time. We'll cover in the next video. We'll see some examples with respect to the vertically opposite angles, and we will also cover what happens when a transversal intersects two parallel lines. What is the relation between angles in that particular scenario? Thank you for watching. Thanks. Bye-bye.